This is the fifth and final video for aircraft observations and reports. In this video, we will discuss aircraft reports, or AIREPs. So AIREPs are basically position reports that are required by ICAO, and the document that specifies how these reports should be made is ICAO document 4444, Appendix A. AIREPs can be either routine reports, in other words, routine position reports, or special reports. Now, with position reports, those are strictly for air traffic control, but if there is meteorological information, that is also included. And there are routine reports, which is just your normal position reports, but that also usually includes temperature and wind and also altitude. But then pilots are able to provide additional information if there is hazardous weather. For example, the AIREP will be classified as a special report if there is severe turbulence, severe icing, severe mountain wave, thunderstorms with or without hail, heavy dust or sandstorms, volcanic ash, and also volcanic eruptions. These days, the reports are made automatically, and this has started about 1991. There are two systems that can do this. One is called AMDAR, the other one is called TAMDAR. Now, AMDAR is the only system right now that is used for AIREPs, and AMDAR was initiated by the World Meteorological Organization back, as I mentioned, in the 1990s. They were flying across the Atlantic and were getting position reports from aircraft over HF radio. But there were a lot of times the aircraft would be out of range, wouldn't be able to get information, and also the oceans, over the oceans, they're very data sparse for meteorological purposes. We'd like to know what the winds are across the oceans. So they set up this system where aircraft would make observations as they fly across the Atlantic, Pacific, or any ocean, even land masses too. And then this information is transmitted either to a ground station or satellite station from commercial aircraft. So these observations help supplement upper air observations, upper air meaning your radiosondes. So most aircraft have some way of measuring their position. Of course, GPS is ubiquitous these days. But also aircraft can measure other things such as their altitude or pressure altitude. Wind can be calculated from GPS, and also temperature is typically measured on aircraft. The only thing that is added, anything that is new, is the moisture probe. And that was supported by a government research project where they put moisture probes on aircraft. And some aircraft have additional moisture probes. Some airlines went and purchased those. So these measurements are made at altitude by, of course, commercial aircraft. This is what the system looks like, and this is how it works. The aircraft makes a measurement and either relays that information to a satellite or to a ground station, depending upon where the aircraft is. Is it over the water or is it over land? That information goes to an airline or other data processing center where the information is separated, and some of that information goes to the airline and other information goes to meteorological services. Here in the United States, it goes to, of course, the National Weather Service, or NOAA. And they use that to assimilate the data into their computer models. So just to summarize what AMDAR is, AMDAR uses the ACARS system. ACARS stands for Aircraft Communication and Reporting System, which is a data link system that was set up by airlines to send or transmit information to aircraft and between the company and also the aircraft, company being, of course, the airline. And typically, ACARS transmits routine information like time on, time off, passenger loading, any kind of dispatch information, but also weather. And now this is what we're interested in, is this weather aspect. So that information, as I mentioned, is linked through ACARS, either satellite or ground, to NOAA. And NOAA has a group or organization which is called the Meteorological Data Collection and Reporting System. And this takes the AIREP information from ACARS and distributes it to the National Center for Environmental Prediction, NCEP, where that information goes into computer models. So these observations are made about 8 times per hour by an aircraft during climb and descent. There are more. Typically during climb and descent, they're more like soundings. In other words, they are kind of providing a temperature and moisture profile of the atmosphere. And they're really useful. These observations are so useful when they're flying across the oceans. Here is a picture which represents 1 day of information. This is all AMDAR information. And you can see that over the United States, there's a lot of information, a lot of flights across the U.S., but even across the Pacific and the Atlantic, and even Asia, there is some information. So it's really good and useful information. If you want to learn more about the AMDAR system, I gave you a few links, and you can go there. And that also has a link to the history of pilot reports. So here's some examples that come in from the AMDAR system, and these are obtained. I obtained these from aviationweather.gov, the Aviation Weather Center. And they plot these at their aircraft observation link. So the first one, the way it looks, it's ARP. It tells you it's a routine report, and these are all routine reports. They give you the airline, UAL for United Airlines, and the flight number. After that, they give you latitude and longitude in degrees and minutes, 40 degrees and 17 minutes north, 104 degrees and 47 minutes west. The time is 16:43 and flight level 380, temperature is -46, wind is 248 at 35 knots, turbulence smooth, sky condition on top, they're on top of the clouds, icing none, remarks, it's a Boeing 757 Series 200, and they are over DVV, the 335 radial, 25 nautical miles, and they're estimating that they're going to be climbing up to flight level or descending down to flight level 360. The next one, similar, you can kind of parse through that, but turbulence, we'll look at the turbulence, light, sky condition, they're in the clouds, and this flight is at 300, flight level 300. There's no icing in the remarks. It's a Boeing 737-900, and it gives you the location. They've got some light chop. And then the last AIREP shows you that they've got a smooth ride and a clear sky and no icing. And they're near El Paso, Texas, but they say that they have a good ride from San Antonio all the way to El Paso. Another system that's used to make automated pilot reports is TAMDAR. TAMDAR, of course, stands for Tropospheric Airborne Meteorological Data Reporting. And what it is, it's a small low-cost sensor that makes observations typically at low altitudes from the surface up to about 25,000 feet. And it uses satellite to uplink or downlink the information that's being measured by the aircraft. And that does that in real time. This probe was developed by a private company called AIRDAT. It was a small business initiative funded by NASA, and they did this after the turn of the century. I think they started about 2000, 2001, and they've been bought out by a company called Panasonic Weather Solutions. But they make these observations, but they don't provide them readily. You have to purchase the information. It's a private company. The TAMDAR probe measures temperature, relative humidity, pressure, and icing. It actually measures icing. And it can also measure pressure, altitude, indicated airspeed, true airspeed, turbulence, and wind direction and speed. So for pilots, it's nice to know if the aircraft is experiencing turbulence or if it's experiencing icing. But as far as meteorologists, they like to know what the temperature, the dew point, moisture in the atmosphere, and other things. So this probe reports as it's climbing 6 times per second to provide a sounding, and also descent. It does the same thing. It reports very frequently to provide a sounding going down near airports, and then en route every 3 minutes. Believe it or not, UND had these on our aircraft. The Seminoles, we had 5 Seminoles with them. Seminoles kept crashing. They kept taking the probe off or having to remove it because they had to fix the airplane. And then finally, we're down to none. We don't have any TAMDAR probes on our aircraft. There is a large project back in the latter part, or the first decade of this century, with Masaba. They were flying these probes on 60 of their aircraft, and the information was really invaluable, but it cost. So here are the airlines that are now operating the TAMDAR probe. If you want, you can purchase the data. And that is TAMDAR. Just know that TAMDAR is for lower atmospheric measurements. You can get pilot reports and also AIREPs, PIREPs and AIREPs at the Aviation Weather Center. Go out to the link and it takes you to a page that shows you all of the aircraft reports across the United States. Also, you can select the age, how much time. You can click on a pilot report. It brings up a little dialog window that shows you what the aircraft is experiencing. It gives you the entire pilot report coded and also decoded. And then you can go down to the bottom and you can request pilot reports and AIREPs surrounding a given location for many miles, and also back in time, I think out to 24 hours it goes back. And that's all I have for you for AIREPs. And this concludes our presentations on aircraft reporting.